So today I will derive some very specific process of the beyond standard model particle. I will consider the happening between ion decay to the jet boson and the neutrino. So this is the case of the two-body decay of the massive fermion into the massless fermion neutrino and the massive boson jet. And this is channel is a possible when the heavy neutrino mass is larger than the jet boson mass. And this is a two-body decay. Today I will use some twice theorem technique, some kinematics with the energy conservations, and some weak interactions and tiny mixing angle between the active and stable neutrinos will be considered. So we can first of all draw the Bellman diagrams of this n to the jet new decay, and I will denote the numbering of the particle as the 1 to the 2 plus 3. And such have neutrinos mixing to the active neutrino by the mixing matrix, Dirac mass matrix over the heavy neutrino mass matrix. And the couplings between the active neutrino and jet bosons are given by the G-jet. And the such a jet bosons interacts by the active neutrino through the left chirality. So I multiply the projection of brightness for the light active neutrino, and the U1s that correspond to the heavy neutrinos pinna. And for the jet boson, there will be the polarizations styles will be multiplied to the matrix element. So we draw the Bellman diagram and bind the amplitudes of the matrix. And the next step is the binding the spin sum using the twice theorem. So spin sum of the amplitude scales can be rewritten by the twice using the Casimir trick. So the M scales are given by the two terms. One is the complex conjugates of the original matrix element and also for the polarizations. And there are average factors, and the UK matrix becomes the y dagger through y, where I use the Dirac mass matrix given by the UK matrix times the babs of the Higgs. And such a bab V and the coupling of the jet bosons that reduces in the jet boson mass. So second of all, the spin sum of the gamma matrix product part that becomes like that. I use the spin summation technique. U1 and the U1s equal the P1s cancel plus M, which corresponds to the heavy neutrino here, numbering 1. And the U2s and U2, such as spin summations, equal the P2 cancel, and I assume that the active neutrino mass is negligibly small. And similarly, we can obtain the spin summations of the polarizations. And the jet boson has the mass, so there are massive terms are also included, unlike the proton. And the first through this part, twice part, we can use the twice theorem. There are gamma 5 terms that comes from the left-handed chiral projections of Bright. So possible there are possible we can neglect the gamma pi matrix and the factor of the 1 and factor of the 1, and in the cancel of the P2 and the cancel of the P1 there are gamma matrices in here, and actually there are no mass term for the active neutrino here. So the odd numbers of the gammas, the twice of it becomes 0. So we only consider the Bohr gamma. There are gamma mu, gamma lambda, and gamma nu, and gamma sigma. So there are Bohr gamma, so we use the twice techniques in here, and just just extract the P2 and P1 through with the index of the lambda and sigma, and the polarizations of the jet bottom mass. That's just given here. And now let's consider the gamma bifactors here. There are gamma bifactor and the Bohr gamma, and it yields the epsilon antisymmetric symbol with the Bohr index, and I just like the aktivtrenden neutrinos, the momentumtrenden also på the jet boson mass. And since that this is the antisymmetric tensor, so same index of the d-menu of the matrix becomes 0, and we can construct each index by using the Einstein notation. So each term, for example, that there are lambda here, so it becomes a p2 mu, and that g nu sigma lays of the momentum index of p1 sigma, so it becomes a p2 mu p1 nu, and there is g mu, so it becomes a p2 dot p1. So similarly, we can construct all the index of the matrix and the momentum. Then first of all, this part yielded the inner products of the p1 and p2, active neutrino and Habe neutrino. And second of all, in this part, there are also momentum of the p3, where is the jet boson momentum supply T. So similarly, we can apply the constructions. Then there are inner products of the p2, p3, p1, and p3 p's. And the final such antisymmetric tensor part, since we will set the last prime of the kinematics, and all the ball momentums that align to the jet directions, then such a momentum product of momentum p1, p2, p3 such thing, and there are ball momentums that are multiplied. But by the antisymmetric tensor, same index becomes 0, so this term goes to 0. So we only consider the inner products of the p1 and p2s, and the inner products with the jet boson momentum. So now that's the second step. We obtain the spin summation of the amplitude scale, and we insert this result in the Paramis golden rule for the decay light. We assume that the last prime, so the Habe neutrinos initially last, and it decays to the active neutrinos and the jet boson. So we can set the momentum sort of Habe neutrinos as the m comma 0, so which is the last prime, and the both the active neutrino is the mass loss, so the energy and the three momentums are same, and the jet boson's momentums, because this is a cm prime, the initial momentums are 0, so the magnitudes of the jet directions, the momentums, three momentums of the jet boson should be the E nu, same with the P2. Actually, there is a minus sign, but I don't want to trick the directions of the jet. So by using that, the energy of the jet boson E jet is given by the m jet scales and the E nu scale. So by the energy conservation, the energy part should be the conserves. So m should be equal to the E nu plus this root. And by solving this, we can obtain the E nu as a secondary particle energy. It is the functions of the jet boson mass and the Habe neutrino mass. And by inserting this result of the E nu to the E jet, we want to obtain the E jet also. And the E jet is given by those functions of the Habe neutrino mass and the jet boson mass. So we will insert this E nu and the E jet in terms of the Habe neutrino mass and the jet boson mass. And already we obtained the inner products of the P1, P2, P2, P3, P1, P3 by using this type of kinematics, and we will insert this result. So there are P1 dot P2, P1 dot P2 in here, and P2 dot P3 located here. We use a P2 dot P3 in a product RAM, and P1 dot P2 so appears down here. So this is for the p3.p2, and this corresponds to p3.p1, and this corresponds to p3 square as the magnitudes of the jet bosons from momentum, and this corresponds to the p1.p2. So after that, I will insert the E nu and the E jet as this just function of the two quantity. So there are some many vectors appear, but for the E nu gives the such a vectors m squares minus m just squares of the 2m. So there are also the E nu here. You can find them E nu and E nu, and there is a E jet. So we can make the some dimensional analysis of the massive parameters. So we can change this of the E nu and the E jet by extracting the mass vector. So it is replaced by this. This is actually the E nu. So mass dimensions are same. So this is also E nu, and the E jet is replaced by that. So there is the common vector. First of all, 1 minus m just squares or m squares all appears each term. So it's the common vectors that goes out, and also the m over the m squares over the both can goes out. So the first terms becomes only remain the number of the two, and the second terms there are 1 plus m just squares or m squares term here, and 1 minus m just squares or m squares term here, and the remaining terms here. And actually the other part such solid angles of the Barami golden rules becomes the all 5 factors, so it make the 1 pi factors disappear, and still you come at tricks that boson master and the m squares are still exist. So by the dimensional analysis, there's just no massive parameter, there's the gamma, and the one having neutrino mass factors disappear. And if we summarize sort of the binary sum, some of the complicated structure, that's just the remaining terms such a form, this factor and this factor. So there are 1 minus x square and then 1 plus x and 2. So it is where the x is here is m just square sort of the having neutrino mass m square. So the binary we just given by the here decay light is the these boxes. So the dimensions are quite consistent. Decay light is one of the lifetimes, so it should be the mass dimension, and there are only mass dimensions that have neutrino mass in the denominator and that boson mass in the numerator, and there are remaining factors. And first of all, we can observe that when they have neutrino mass capital M and the jet boson mass m jet equal, then this factor becomes to 0. So it is only allows for the having neutrino mass is rather than the jet boson mass. So this is a kinematically allowed condition, and when the having neutrino mass is smaller than the jet boson mass, this process is forbidden. So I want to start some of the techniques of this two-body decay of the massive fermion to the one massless fermions and the massive gauge boson. So first of all, we draw the Bowman diagram and binding the matrix element. That is very simple. On the second, we use the spin summations and trace theorem, and there are some of the polarizations of the jet bosons that we use, and we set some of the kinematics. We use some of the last prime of the having neutrino mass and the mass last of the active neutrino mass. That's a very good techniques, and by using the two-body decay energy conservation, the energy of the neutrinos and energy of the jet boson mass can be expressed by the jet boson mass and the having neutrino mass. And actually there are no active neutrino mass because there's a very negligible. So we insert such as a setup of each momentum Pn, P nu, and P jet, and we can summarize it against some of the decay light, some of the dimension per factors, and some of the additional correction, and then we can check there are some step functions of the kinematically allowed condition. So this is a very good example of beyond standard model particles decays, and then maybe it's a very usable and practical examples to do the research of the something.